everyone. My name is Igor Bondarev and I'm software developer here at ENCY Software. The ENCY is a racing car and maybe not, or rather whole lineup of them: ENCY Clouds, robot, machine maker, tuner, etc. User, he is a driver and he is happiest when the car responds to his lightest touch, and the API is everything that allows him to set the car up his own way so he can win. Over the past year, the API has gone through the serious evolution, and today, without false modesty, I'd like to show it off. What's new, what's become dramatically easier to use, and where, to my mind, a real magic happened. To start with, the OpenAPI, ENCY OpenAPI, is built on Component Object Model COM, and that means that your extensions can be written in C#, C++, or Delphi. And today, all my examples will be in C#. One API spans all ENCY products and fully documented. This documentation is machine readable. That means that it serves not just people, but AI as well. Our ENCY OpenAPI is two-way. You don't just read ENCY state, you control it. Change parameters, change projects, run calculations, and so on. And you work not with files, you work with the live system. You may be, just ask ENCY to change a parameter and it will reflect it away right now without no import-export step in between. Your extension can be a DLL that ENCY loads and runs itself with maximum speed and direct access to the live system, or you can build your own application, just pull in SDK as a dependency and you'll be able to drive ENCY through inter-process communication from the outside, like two programs will interact as equals, or don't call the API at all. You can just subscribe to events inside ENCY and react to what user does. Okay, now I just want you to show the best proof of what I'm saying, the real extension, which is already published on GitHub under the name Part Calibration Workflow. The goal of it is simple, just to calibrate position of parts on the machine. Yep, we'll have a probing operation. This operation will generate an ENCY program. The machine will run it and report back a set of probing points, set of measured points. From those points, we figure out how the part is actually sitting, and we just rotate it to match. And that's it. Okay. As you see, I select faces I'll calibrate against. Please look surface points counter. It's leaf. That means that API can understand when you select something. Right now it's just counter, but you can build any logic of your own on top of it. I set number of creating points and where to put them. This list is also we get through the API from the geometry tree. We can read it. I press a button and you see new folder with 8 points have been created. We can do that through the import API or directly through the GCAD, which we've also surfaced by the API. Through the API, we can change the machine. Look, I press the button and the machine have been set to another one. This machine we'll use for measuring. Okay, I also want to add some setups. We can do that also through the API, but let me do this directly so you can understand what happens. Otherwise, it should be like a magic. Then I have to, of course, select these 3 points to provide them to operation. It's not so easy as usually for me. The second one and the last one. Now I press a button. And as you see, new operation through API have been added. This operation contains in his job assignment 3 probing, 3 measuring cycles. All that works through the API. Then I can just run calculation, then post-processor, and get back the program that you'd give to the machine. And it all just works without any other things. I can run also simulation, but not now. Let's run. I don't have here on the stage a machine, so I have to emulate. Let's make clear 90 degrees rotation about Z-axis, run emulate, get the points and import them. Let's return back. This is the points. Let's return back to the measuring points. You see, new 3 points have been added, and all that's left is to get the rotation matrix. Through the API, you have point snapper helper. It can project each point to the nearest surface, and it all just works. Or maybe you can build your own logic based on top of it. And all that's left, no, it's not just this left. We have to get this rotation matrix, as it's on the video. I get this 90 degrees by this helper, and all that's left is to apply the result. Here I have 3 options: create local coordinate system, move a workpiece setup, or maybe transform 3D model itself. Okay, let's for now make the second one. We have to refresh number of stages, then apply the result, and you can see that through the API, this part was just rotated, clear 90 degrees rotation about that axis, and it all just works as in this example. Okay, all this power comes with a catch, a problem many of you have already run into, a high barrier to entry for creating your own extensions. The point is, ENCY contains an enormous amount of functionality, and that means hundreds, maybe thousands of interfaces. Believe me, I know what it is, and their methods. So let me introduce you new feature of the past year, the one that will help you to create extensions without no code at all, macros. So the technologist sets up the machine once, the way he sees the fit, tools, operations, passes, cutting modes, and so on. And ENCY remembers it, ready to replay tomorrow on the different part, in another project, and so on. And it is very important that under the hood, it is absolutely the same API. Every button you press, every edit you insert makes the same API call, but through the interface, not through the editor. And what else? This recording, it is not just a snapshot for a single part. No, you can promote any input to be a parameter. So ENCY will ask to fill it before it will run it. And such macro, it is easy to share because it comes along with all its resources, all its environment, just in one packed single file. You can drop it into a chat, you can send it to a colleague, or maybe attach to a bug report, and all will be opened in one click and worked as it should be. Let me open macro window. Just start simple recording and then work as usual. For example, create whole machining operation, select this whole and add it to job assignment. You see ENCY records every my step as I go. I have to save it. There are 2 options. .NET will create a entirely C# extension. The second one, SPR, will build a script which also can be run from the ENCY. I have to specify its name. And now you see this name is in the list. Very important thing that under the hood, this macros is just plain text. You can easily open it, fix it, read it without any binary magic. Now let me run this macro again, and you'll see that everything works. The second operation have been just added, absolutely the same as the first one. As I've said before, any macro can be edited. So let's edit it, and ask not to remember this phase I've previously selected. Save it. Now when I run the macro, it will ask me, please select the phase. So I select such phase, next run, and new operation with absolutely another whole have been added. Let's do it once more. Okay, and we need run. So 4 operations with 4 holes have been added. So for now, we've been going from actions to operations to the project, but we have another option. There are 3 options of capturing, of making macro from the project: machine setup, workpiece and stock, and strategy. I start recording, and you will see that new macro have been created with with its initial state. Let's just save it. Let's just make new project like nothing was happened and rerun this macro with 67 steps very fast, so it works as it should be. 4 operations have been added. Everything works fine, and that was good. Thank you. One more thing I've said, it is editor, so let's just open it in editor. You see VS Code. Yes, VS Code contains debugger, contains code navigation, syntax highlighting, and so on. As I've said, it's just plain text. You can easily fix it. You can put debug points and debug how the ENCY is working. I really enjoy that moment when you can stop ENCY, just do something and continue. It's really magic. Okay, and what else? In ENCY 3, we've taken publishing, we've taken import and export extension and macros to a whole new level. I remember previous year I've promised you something that will change game rules. A store, a marketplace for your extensions. The picture was this, like the dealer makes an extension, puts it on its shelf, and customer sees it immediately, and in just one click he can install it. Well, now it is reality. It is the feature which is already inside ENCY. You see it on the screen, and now publishing extension is as easy like sending a link, nothing else, nothing more difficult. But the main breakthrough of this year is AI development. Frankly speaking, I've handed this topic to my colleagues, but AI is not only their story, it runs through my corner too, through the API, because previously API was just a contract between ENCY and users. Now API is a contract between ENCY and AI, as you understood from our previous presentations. And the stricter, the cleaner that contract, the smarter AI works through it. And I can promise you, these contracts are very clean and are very strict. I build them. So AI works as a magic. And of course, any other work on the API like documentation, like tests, like clean interfaces now pays off twice over. The same information feeds both people and models. Okay, so now what should we do for the API, for the AI? First, documentation as the main artifact. We need more documented examples, more documented edge cases worked through. We need more live scenarios. Second, each test now is a ready-made scenario. Test is no longer just an insurance against regression. Now test is something that can demonstrate the AI how the real API interface behaves. Third, our community is our data source. Every published extension, every shared macro becomes a material the model can learn from. And of course, the bigger the ecosystem, the smarter the system works. And for the next year, our plans, frankly speaking, I'm not sure that I will do them in the next year. I think we need just maybe a month or 2 months. Everything changes very fast. But what can I imagine? First, macros tuning. You've got a good macro and it really good works, but you can ask AI to improve. How you will do that? You will give a macro, you will give an ENCY instance and ask, please run with your own parameters 1000 times, 100, and so on. Just make the best one. The second, what can be clicked should be available in script. The goal is simple. What the user can do through the interface should be available through the API and macros, of course. And binding to geometry, not by name, but by the meaning. For example, the top plane, the wall of a pocket, or axis of a hole. Yeah. And what I want to say else. Over the past year, API, of course, have gone through a serious evolution, but the main evolution was that it became much simpler. We've hardly worked on this, and of course, a lot of work had been done under the hood. It is invisible, and as I always say, we need your help. We need your ideas. We need your own tasks, and of course, GitHub is open, documentation is open, and I am personally open to your ideas. Thank you.